Concentrations of protons and hydroxide ions make a solution more acidic or basic, and scientists use something called the pH scale to describe how acidic or basic a solution is. In any aqueous solution, the product of proton concentration and hydroxide ion concentration is always 1 times 10 to the minus 14. If you have an increase in proton concentration, you'll have a decrease in hydroxide ion concentration, or vice versa, to always maintain this product. Here on the right is shown the pH scale. The scale ranges from 0 to 14 and is a logarithmic scale based on the concentrations of protons and hydroxide ions. As you move up to the top of this scale, you increase in acidity. As you move down to the bottom, you become increasingly more basic. But how do you determine the pH of your solution? We do that with this equation. The pH is equal to the negative log of your proton concentration. Now, in order for this to be any sort of useful, you have to know some of the variables. And usually, we just have to know the proton concentration. But we could also be given the pH and determine the proton concentration. But we'll start as if we were given the proton concentration of 1 times 10 to the negative 4. We can plug that into the equation, take the log of 10 to the minus 4, and that gives us minus 4, and then work through to get rid of the negatives, and that gives us a pH of 4. We can do it again with a proton concentration of 10 to the negative 3. If we take the log of 10 to the minus 3, that gives us minus 3. If we work through to get rid of the negatives, we get a pH of 3. Now you may have noticed a trend here that as we go from a pH of 4 to a pH of 3, on the scale it tells us that we're becoming more acidic. As the pH decreases, the proton concentration increases and you become more acidic. There's an easy way to know what your pH is as long as you know your proton concentration. Say you're given a proton concentration of 1 times 10 to the minus 4. That would be a pH of 4. A proton concentration of 1 times 10 to the minus 3 would give you a pH of 3, and so on. 1 times 10 to the minus 2 would be a pH of 2, and the rest of the scale works the same way. And that's how you know how basic or how acidic you are. However, if you only know your pH, such as in a lab, if you take a pH meter and determine the pH of a solution, you can determine the concentration of protons and hydroxide ions in that solution. Say you determine that your pH is 4. Well, then automatically you'll know that your proton concentration is 10 to the minus 4. You can plug that into this equation at the top because we know the product of proton concentration and hydroxide concentration has to be 1 times 10 to the minus 14. So if we plug in our proton concentration of 10 to the minus 4, then our hydroxide ion concentration has to be 1 times 10 to the minus 10 to give us a product of 1 times 10 to the minus 14. Now the opposite would be true. If you were given your hydroxide ion concentration, you could determine your proton concentration, and then you could use that proton concentration to determine your pH. So no matter what you're given, you can almost always find the pH of your solution.